Hi guys, this is Dr. Divya Pradhan, and today we are going to talk about a continuation of organs and tissues of flowering plants, the differences in the internal anatomy of dicot and monocot plants. Okay. Alright, so here is the internal anatomy of dicot and monocot stem. Now unfortunately this is an online class. If you were taking a traditional class, we actually cut a cross section of both dicot and monocot. For dicot we typically use the sunflower, for monocot we use corn, and as you can see the internal anatomy of a dicot and a monocot, let's look at the differences. Alright, let's look at the first difference. The first difference is that the hypodermis in a dicot plant is collenchyma. So the hypodermis, which is just below the epidermis, is made up of collenchyma in dicot, and it is sclerenchyma in a monocot. Okay, that's the first difference. 2. Ground tissue is differentiated into endodermis, pericycle, and pith. So there is an endodermis, there is a pericycle, and there is a pith, which is right in the middle that you can see. Here the ground tissue is not differentiated. As you can see, there is no difference. Here there's a clear difference. Okay, here you can see that there is a ring and your pith and cortex is separated. Here the ground tissue is not differentiated, but it is continuous mass of parenchyma. So there's a continuous mass of parenchyma, so no differentiation in ground tissue. Okay. 3. Starch sheath is present. Well, what is a starch sheath? Starch sheath, let me write this down. Starch sheath is a layer of cells in the inner boundary of cortex. So inner boundary of cortex, right here, there is a layer of this starch sheath which is present here in a dicot but absent in a monocot. Okay. Stem. Pith, obviously pith, which is the central core, which is the central soft spongy tissues. This is present in a dicot but absent in a monocot. No difference. We talked about this before. Pericycle. The 5th point is pericycle is present. So what is pericycle? Pericycle is a layer below the endodermis. So this pericycle layer is present. It is pericycle. It is present in a dicot. It is absent in a monocot. And then medullary ray. What is medullary ray? Medullary ray, let me write this down. Medullary ray, it is present in a dicot. It is absent in a monocot. Medullary ray is a sheet of conducting tissue which runs radially through the vascular tissue. What are vascular tissues? Xylem and phloem. The 7th point is the vascular bundles are open. So vascular bundles in a dicot stem, they are open. What do you mean by the word open? Well, open means if cambium is present. If a cambium is present, you can see a vascular cambium here. If this is present, then the vascular bundles are open. There is no cambium here, so vascular bundles are closed in a monocot. Okay, and these vascular bundles are arranged in a ring. As you can see here, the vascular bundles are scattered. They are scattered. So here it is a ring form, here it is scattered. And then last but not the least, phloem parenchyma. Phloem parenchyma, this is present here and here it is absent. So these are the differences between a dicot and a monocot stem. Your book may not go through these details, but I really would urge you to look at these differences in as much detail as I have explained. Okay. All right, what is the difference in the internal anatomy excuse me, of dicot and a monocot root? Well, first thing, dicot, let's look at it. So in dicot and monocot root, the vascular bundles are 2 to 4. Okay, rarely, very rarely they will be 6, but the vascular bundles are 2 to 4. What about here? The vascular bundles here, these are numerous. Okay, these are numerous. Cambium, Once again, cambium, remember, comprises, this cambium is the one which is responsible for secondary growth, and this is typically seen, this is typically made up of meristematic tissues, which are the immature tissues. They can divide and form all other cells. Here the cambium is absent. Okay? What about the xylem? The xylem are, what happens is that these are small, so the xylem are small, and these are polygonal. They are small and polygonal. This would be the correct shape. Here the xylem are large, so the xylem large. Okay? Now pith. Here the pith is absent. We are going reverse. Remember, in the stem, in a dicot stem, pith is present. But in a dicot root, pith is absent. Here we have a pith. What is pith? Remember what I said? Pith is the soft, inner, spongy tissue. So pith, once again I repeat, is absent in a dicot root, but present in a monocot root. And last but not the least, cortex. So cortex, what happens is, this is large. This is the cortex. This blue region is the cortex. Here the cortex, sorry, excuse me. This is the cortex. Here's the cortex, not the blue. This is the region. This is the cortex, okay? Here is the cortex. The cortex is small. I think this is all of the differences that I have for the internal anatomy of dicot and monocot root. Now last slide, and that is the difference in the internal anatomy of dicot and monocot leaf. Now remember, you can always identify the difference between monocot and a dicot leaf. Why? Because in a dicot leaf, it is the upper layer and the lower layer are different, okay? So it's dorsi-ventrally differentiated. The upper, you'll notice, just any dicot leaf, you will notice that the upper part is dark, the lower part is light in color. Whereas in monocot, the upper and the lower part is exactly have the same coloration. Also the venation. Venation means the veins. They run parallel. Here, the veins are varicose. Varicose means in a network. All right. This is the outer anatomy. But what about the inner structure? What about the inner anatomy? Well, first and foremost, the nature of orientation. In dicot leaf, like I said, dorsiventral, and these are isobilateral. That means, fancy word, upper and lower surface same. Mesophyll. So the mesophyll in a dicot leaf, here, this is differentiated. It is differentiated into an upper, tall, column-like cells, which are called the palisade cells, and the lower cells, which are again round or polygonal, and they're loosely arranged with a lot of air spaces. That's called spongy mesophyll. So this is why, this explains why a dicot leaf is darker on the upper surface. Why? Because there's lots of palisade cells, and these palisade cells are richly supplied with these black dots which you are seeing is nothing but the chloroplast, which contain chlorophyll, the green pigment. The spongy mesophyll is loosely arranged, lot of airspace, so fewer of them. So obviously they have less chloroplast, less chlorophyll, lower surface lighter, upper surface dark green in color. In a monocot leaf, you do not have this differentiation. It's undifferentiated. There is nothing called palisade, mesophyll, and spongy mesophyll. It's just mesophyll. So what about the xylem vessels? The xylem vessels here, there is in a dicot leaf many protoxylem and metaxylem vessels. So here in a monocot leaf, there are two protoxylem. You can see the protoxylem, and there are two metaxylem. You can see the two metaxylem also, small metaxylem in each bundle. So here there are many. Proto means these were first formed, that's why they are big, large. So the protoxylem, they are two protoxylem and two metaxylem. In a monocot, in a dicot, there are many protoxylem, many metaxylem, okay? And then the bundle sheath extension. The bundle sheath extension in a dicot is made up of collenchyma, whereas the bundle sheath is made up of sclerenchyma. So here the bundle sheath extension is made up of collenchyma, and here the bundle sheath extension is made up of sclerenchyma. All right. So with this we come to the differences of the dicot and monocot leaf. And once again, if you have any questions or concerns, you do not understand something, please stop by my office. Otherwise, you can always call me, email me. I will make myself available. And once again, I thank you for listening and giving me your time and attention.